Hello, welcome to this video. In this video, we will see a question based on projection of solids, projection of a cube. The question is, draw the projection of a cube of 50 mm base edge resting on one of its corners on HP when the body diagonal of the cube is perpendicular to VP. This question may be asked in another way also. Draw the projection of a cube of body diagonal length 86 mm when it is resting on one of its corners on HP with the body diagonal of the cube perpendicular to VP. Now, if the body diagonal length is given, you want to calculate the edge of the cube in using this equation. Body diagonal is equal to 86 millimeters. That is r into square root of 3 is equal to 86 mm. This is the equation for which connects the edge length and body diagonal. So r into square root of 3 is equal to 86. So from that you can get r equal to 86 by square root of 3, which is equal to 86 divided by 1.73, which is equal to r is equal to 50 mm. So in this way you can calculate the length of edge length of the cube when body diagonal is given. Now first, since it's a cube of 50 mm edge, first we will draw a square like this. Square with one. First you draw a reference line like this. Mark a point here. From there you draw a line at 45 degrees like this, and a square should be in this. You have to construct the square in this way, because we want to. It is given that the edges, the cube is resting on a corner, so that corner should come on the right side. So you start like this from here. From a point here, just draw a line at 45 degrees like this, having length of 50 mm, and in that way you have to construct the square. So name the square as A, B, C, D, E, F, G, H. The A, B, C, D are the points coming on the top face of the square, whereas E, F, G, H are the corners on the base of the cube, bottom side. Okay, so those points are invisible, so those points are shown inside the bracket. Now from all these 4 points you just draw projection lines like this. Since it's a cube, the height of the cube will be the edge length. From here you can mark 50 mm like this, 50 mm, and you just connect or draw all those lines like this. Connect all those lines. Okay, so here you can see this will be the A dash, and this is B dash, this is C dash, and D dash. These A, B, C, D are the top points. In front view we have a dash. Okay, A dash, B dash, etc. So those A, B, C, D, E, A, B, C, D, E, A, B, C, D, E, A, B, C, D are the top points. So A dash, B dash, C dash, and D dash. D is invisible in front view, because here if you consider the points outside the bracket, first B is coming, then D is coming, so D is invisible, so D dash is invisible. Similarly, the base points are E dash, F dash, G dash, and H dash. H dash is invisible. Now we want to copy this cube here in such a way that this body diagonal is parallel like this. Okay, so first you mark a point here, and this height, this length from here to here, this length from here to here you mark from here like this, here like this. This length from here to here you mark here. Keep some distance and mark that height. This distance from here to here you mark here, and this length you mark here, and this length you mark here. Here we are using a chain line to show the diagonal. Okay, so how we are getting this line is just connect this point to this point and draw a line from here to here, but only you need to draw a line from here to here only. Instead of drawing a line from here to here, just draw a line from here to here, and this line you have to use chain line, this diagonal. So you are copying this diagonal here. So first you mark a point here, and G dash to this distance you mark here, and this line, this length line you mark towards right side, and this length you mark towards left side. So you can get this. Then now you want to connect all this point like this, here to here and here to here. Now through this point you draw a line parallel to this line like this, parallel to this line, and through this point you can draw a line parallel to this line like this, and then midpoint of this line, connecting midpoint of this line and this midpoint of this line, you can get this line. So in that way you can just copy this front view here in such a way that this diagonal is parallel like this. Now name those points with suffix 1. Okay, a dash b, a1 dash, b1 dash, c1 dash, d1 dash, etc. e1 dash, f1 dash, etc. Okay, so those here also d dash and h dash are inside bracket. Okay, so here you have d1 dash and h1 dash are inside bracket. Now next what you want to do, you just draw projection lines from here like this, parallel lines crossing this point. Okay, from all these 4 points, 1 2 3 4 4 points, this point and this point will be a common line, so you have only 3 lines parallel to the axis. Just draw parallel lines, parallel projection lines to the reference line. Now you want to draw projection lines from e1 dash to the locus of e, here e1 dash to e, a1 dash to a, b1 dash to b. In that way you have to connect all these 8 points. You have to draw projection lines to the corresponding lines here. Okay, any point you can get. If you want to get b, you just draw a line, vertical line like this from b, and here you have b, so this will be the b1. So in that way you can get all the points. Now if you can get all the points here, all 8 points here, name those points and connect those points here like this. In this you have these two, this line and this line and this line will be invisible in top view. This is the top view of this diagram. Okay, this is the top view of this diagram. So in this case these 3 lines will be invisible, so you want to use dotted line to represent those lines. Now you want to copy this diagram here in such a way that now once you, here in this diagram the diagonal is parallel. Once you rotate it, this diagram through 90 degrees, this diagonal will become perpendicular. You want to make this body diagonal perpendicular. So this, now this is parallel. If you rotate this diagram through 90 degrees, this will become perpendicular. So to make this, copy this diagram in such a way that you want to rotate this through 90 degrees. For that, just draw a vertical line like this, mark a point here, and from that point you mark this distance and this distance. That will be same. Okay, same distance, this distance here to here, here to here, here, that is c1 g1, g1 a1 and a1 e1. You mark those distance here and draw perpendicular lines like this, and from here g to d distance you mark here, and g to b, g1 to b1 distance you mark here. Similarly a1 to h1 distance you mark here, and a1 to f1 distance you mark towards right. So you can draw these lines. Now once you connect all those points, you can get those points. Once you connect all those points, you can get a shape like this, and you just erase unwanted lines. So you can get a b c d and e f g h. So this is the after connecting all those points, you can erase unwanted lines, then you can get this diagram. So now you have copied this diagram here in such a way that this line is perpendicular like this. Now you want to draw the projection lines from here like this. From all these points you draw projection lines. You have all these points, you have 4 lines, projection lines, including this base you have 5 projection lines. Draw 5 projection lines. You have this point and this point will be a common point, so you have only 1 line. So now from here from all these points you just draw projection lines to the corresponding line here, from D to D, C to C, C to C, and A to A, like that. If you draw projection lines, you can get some points here. All those 8 points you can just you can get there. Now if you connect that A B C D E F G H, you can get a diagram like this. Here in this case, since the point E and C will be a common point here, so, and since we are rotating this diagram in such a way that E is coming downwards and C is to that side, E and C are is common point here. Okay, this E and C are coming on the same line. So when you in front view, from here if you see E and C only will be a single point. So in that case E is coming first, then C is coming, so E2 dash and E2 dash will be visible and C2 dash will be invisible. So C2 dash we are marking inside bracket. Now finally you can get a diagram like this. Since the point E is coming this side, the face EFGH, the point E is coming this side, so EFGH face will be coming towards observer. So in that case the point EFGH will be visible, and corresponding perpendicular line also will be visible, and the other face, which is ABCD will be invisible. In that, border will be visible. So this is the final condition of the diagram when the body diagonal is perpendicular. So body diagonal is actually EF. When it is perpendicular to, here you have it is inclined and here it is parallel. Now here it is perpendicular. When it is perpendicular, the E and C, when EF is the body diagonal EC, body diagonal EC is perpendicular here. So when it is perpendicular, E dash and C dash will be a single point. So this is how you draw the projection of a cube when the body diagonal is perpendicular. Thank you very much for watching this video.